So greetings and welcome to the ZTRM Operations Analytics demo. I'm Mark Perillo, Technical Account Manager at RSD, and I'll be running the demo. We're demoing ZTRM Operations Analytics version 1.2. I'm contacting the server via my Chrome browser, and you received an overview of this environment in the webinar presentation. For reference, we'll be using a few common acronyms and terms I just want to mention here. We'll be talking about the R4H, or the Rolling 4-Hour Average, that is used by IBM in their SCRT, subcapacity reporting tool, to calculate your MLC, or your monthly license charge, for eligible mainframe product pricing. The MLC is measured in MSUs, or million service units. ZTRM Operations Analytics provides stakeholders information about the system by bundling related KPIs, or key performance indicators, into dashboards, or collections of KPIs that provide specific information. As you can see on the screen here, under the dashboard pull-down, these first four dashboards listed are the ones that are included with the product as an out-of-the-box feature. These four are the Business Application Manager's Dashboard, the Director Dashboard, the IT Operations Manager Dashboard, and the IT Performance and Capacity Manager's Dashboard. Technical and non-technical folks alike should have few problems using these dashboards. They're very intuitive. They will get insights into the resource consumption that contributes to your rolling 4-hour average. I'm going to review two dashboards in this demo, the Director Dashboard and the Business Application Manager's Dashboard. They serve two very different stakeholders and are good examples for dashboards. The Business Application Manager's Dashboard will actually be used to do an MSU optimization, which is a new feature with ZTRM Operations Analytics version 1.2. So starting with the Director Dashboard, this dashboard has 6 KPIs. We'll cover the first 4 in this demo. Right now we're actually looking at the R4H peaks, giving us the daily R4H for all of our systems on the machine, or CPC. You notice that our peak this month occurred on the 5th and the 12th of February. Each entry in the graph gives a day's total, and this KPI is presented as the full width of the screen. I'm going to scroll down now to the next KPI, the R4H peaks by entity. We'll see we have the same peaks in the same days, but the consumption is actually shown by entity. This is achieved by grouping together the LPARs running on our systems into meaningful groups that make sense to the business people. Our demo system groups are determined by lines of business in a financial company. Okay, both of the first 2 KPIs we're looking at February 2nd to February 20th. The next KPI is the R4H analysis by workload type. This is giving us 1 day's worth, which happens to be yesterday, showing the breakdown of the WLM components of batch, transaction processing, and other. And it shows us when these workloads are busy and how many MSUs are consumed during the day relative to the R4H, which is the line going across in red. The last KPI that we'll cover in this dashboard is the MSU usage for the last 13 months by entity. And this KPI gives us a big picture for all of our entities running monthly, and it gives us the ability to size the system workloads over 13 months and look at their overall contributions to the MSU usage. Okay, so that completes our review of this dashboard. We'll be spending the rest of our time in the Business Application Manager's Dashboard. And the first thing you'll notice is that the first 2 KPIs that we're looking at, the R4H peaks and the R4H peaks by entity, are the same ones that we saw previously. The only difference is they're shown here side by side as opposed to full width. Spoiler alert here, there are some KPIs that are actually found in more than one dashboard. This allows us to have some common focal points when we start talking between stakeholders. Okay, well, we've already reviewed these first 2 KPIs. If we go down a little further, these are the KPIs that will help us do an MSU optimization. The R4H analysis by application provides MSU consumption for the applications that are running on the system. And you can see the top consumers KPI to the right, which is a complement. And it allows you to group together the different job names to give a meaningful category for the analysis on the left. In our particular example here, we've actually already done an optimization for the HR application, which is shown here in purple. It's a small application workload, but it is occurring during our peak. We'll get more information on that later. Now scrolling down, our next two KPIs are the R4H analysis by program category and the top programs that make that up. As before, the KPI on the right allows us to map the appropriate programs into appropriate categories so we can get meaningful groups of program products that are often run on the same system. We've already added an MSU optimization for our EOS view, RSD software for online viewing, that's shown here in yellow. It's a small workload that contributes to the R4H peak, and therefore it's a good candidate for an optimization. In this demo, we're going to be looking at a straightforward solution to reduce the R4H. Let me expand this KPI. The IBM TDS batch job is running every day from 2 a.m. to 8 a.m. In this time frame, it is contributing to the R4H. We're going to reschedule this workload to start at midnight, and it should complete by about 6 a.m. Excluding TDS here on the graph shows that this change could give us a simulated R4H savings of 12 MSUs. We can save money just by changing our schedule once we understand our MSU consumption and how the different workloads contribute. At this time, with this TDS selected, the Add MSU Optimization button is available. This window is going to allow me to basically add an optimization to the system, which we'll look at shortly. So it's going to be a schedule change. I cannot type today. Okay, there's a peak impact of 12 MSUs. I'm going to say that we're going to realize a 6 MSU savings. This is only a scheduling change, so I'm going to be optimistic and say it'll be 2 months for us to implement this change. And the frequency is going to be monthly. It's going to contribute every day for the monthly rolling 4-hour average. Once all these fields are filled in, the submit button is available, and we've actually got an optimization added to the system. Okay, so that's how we do an MSU optimization. We're going to finish up by going to the actual settings and administration page within ZTrim to look at this optimization. Okay, looking here on the system, we'll see there are actually 3 optimizations. The first 2 that were already in the system that I mentioned, the HR application and EOS view. The HR application is actually a programming change. It's going to take 7 months to implement. It's being done by the business, and we're going to see a savings of 2 MSUs. Our EOS view change is going to save us 6 MSUs. Will take 3 months to implement. It's going to be achieved by running the EOS bridge software to offload that viewing workload to an EOS 360 for open systems environment where it won't contribute to the rolling 4-hour average. If you look at our optimization, the schedule change, the first thing we notice is there's not an owner assigned. This will be done by our schedulers. I'm going to actually put it in for IT. So we now have 3 optimizations on our system. We're almost done. At this point, I want to quickly go to inputs and show that currently in our environment, we have 1 CPC, we're dealing in US dollars, but we have an MSU annual cost of $15,000 per MSU per year. I'm going to go back to optimizations and actually show the amounts here. That's how they're derived. So we can see that these changes are going to make substantial yearly savings to our environment when they're implemented. To enforce this, I'm going to go to our summary and also show amounts. And we'll see that initially, after the first month, when one of the optimizations are in place, we don't see any MSU savings, but within 6 months, we're up to saving 41 MSUs if our projections are correct. And within 2 years, we've projected saving 292 MSUs. If we actually do we had them shown on the far right, we'll see this is a savings of over $350,000 just by putting these optimizations in place, which is a huge savings, and is basically attributed to this tooling giving you the capability of understanding the MSU optimizations that can be done and how to put them into the system and realize the savings. At this time, if you have people that aren't using ZTrim but need this information, you can also send this report out. You can export it to a PDF, and they will get these 3 summary screens that we just showed delivered to them as a PDF. Okay, that was a brief demo highlighting some of the capabilities.